Hey everyone, welcome back to the channel. Myself Ajay, and I am actually a technical trainer in this channel, and mostly I post some of the preparation videos regarding whether it's pseudocode, coding, or anything. And I coming to myself, like I work as a IT professional, and I am working since almost 4 years at one of the FANG company. That's quick intro about me. Those who don't know me, and yeah, I think for the previous batches definitely they know, because I have been like giving videos about TCS and all the companies. So yeah, so for today we are gonna discuss mainly on the Infosys exam preparation, and for that we are gonna concentrate on pseudocode questions. And if you see, there are like multiple sections in the Infosys exam, and one is pseudocode, and we mostly it will be to trace out output or to determine the error or something. So there'll be a snippets given, and you have to answer for that. And remember, this is a pseudocode. Don't think in the perspective of any programming language, whether it's Java, Python, C++, anything, because usually people get confused, because if we have an elements or any number from like, maybe a simple example can be a for loop. In here, most of the for loops, if you see the question, it starts from one index rather than zero. So consider that. And also, if the for loop is given like for in the for from 1 to n, in for the people who use Python, they assume that 1 to n means 1 to n minus 1. No, but in pseudocode, 1 to n means n is also included. So remember those. So I would request, like, if you keep on practicing such questions, you will be able to understand how exactly solve the pseudocode. And coming to this video, so we are gonna like basically solve it's a long short video. We're gonna solve all 50 questions at once. And I try to cover most of the patterns and most of the operators and a lot of things. So I would request just practice with me. And this is just an awareness video, and don't think that just practicing this will like it. This it's just one of the practice session. So I would request practice this, and after this video, try to find more patterns of it and do practice. And if you need more preparation, then do comment. So let's get started. Coming to the first question, let me take a pen from here. Okay, yeah. So what is printed? For a equal to 1, from I from 1 to 6. So we have I, which is going from 1, 2, 3, 4, 5, 6. Then I mod 2 equal to 0, then a equal to a into I, else a equal to a plus I, and if and for print a. So basically we have to at the end we have to print the value of a, and the value of a getting modified by two cases, when I mod 2 equal to 0 and when it's not. So that means I mod 2 is equal to 0, modular division. That means the remainder is 0 when it's an even number. So the 2 is given, so any number that is given is divided by 2, and that would result in 0. So you see, so any even number will go to this case, and any odd number will go to this case. So let's trace out the output. The first value a is given as 1. For the first question, 1 and 1 is odd, so it will go to a plus I. So 1 plus 1 is equal to 2. And for the second index, 2 is even, so that means a into I, and a value currently we have updated to 2, and the I value is pointing to 2, so 2 into 4. Always remember, like, if you are like if you can map it in mind, that's well and good. But if you're a beginner, if you want to trace out the output, and if it's a for loop or while loop, try to give the indexes here. And if it's an a this is there is no array, but if it's an array, try to add the indexes array here according to that, and use a pointer. Use a pointer in your notes. This way you can understand, and you can remember, okay, I have already traversed one, this is a second, and here into I, and into whatever the elements that are gonna come in the loop or in the program, you can just trace out. That's a very easy and basic way to like solve the pseudocode. Okay, let's continue. 2 into 2 4, so we got a equal to 4 now. Then index got updated to 3, and for 3 it's an odd, so that is a plus I, which is 4 plus 3, which is 7. Now 3 is done. Coming to 4, 4 is even, so even we need a into I, that is a value 7, into I is 4, that is 28. So now this is done. Then next 5, and it's an odd, so 28 plus 5, that is 33. Yeah. Next we have even equal to 6, which we need to multiply, that is I think 33 into 6, 6 is 18, 18 plus 6 is 18, 198. Yep, so 190 is the answer. So mostly you'll be given an MCQ, so you just have to select the answer, but if by chance any text was given, you have to enter that number. Okay, let's move on to the next question. Yeah, it's a string given a b c c, count equals 0 for I equal from n length minus 1. Length minus 1 is given because if you see in the second in the next line, I plus 1 is given. So if I plus 1 were not given, that means like this will go TLD and we want to check here and we'll get an index out of bound exception. So that is already been taken care, but in case some question comes up and find out the error that can have, so that in that case you have to identify what kind of exception that can raise. That can you can only figure out if you know the answer concept of exception or errors. So yeah, coming to this question again, so if s of I equal to s of I plus 1, then count equal to count plus 1, and if n for print count. So that means they're actually comparing S of I and S of I. That means they are comparing whether adjacent elements are equal or not. If it equal, that increase the count. So count is initially with 0, and if it trace out AA is 1 and CC is 1, are the two only pairs that are equal, so count will be incremented 2. So if we do print count, the answer will be 2. Answer 2 is the correct answer for this. Next, going to the next question, we have 2, 4, 6, 8, 10, and sum equals 0, I from 1 to length of I for j from I to length of array, sum equals sum of array j minus array of I, n for print sum. Okay, so we have going to print the sum, and there is a lot, but this is gonna be tricky because this is a 2 for loop. So when there's a multiple loops are given, that's where even if you miss a small thing in between, so it's gone. Like you will not gonna end up getting a correct answer at all, and you cannot trace back. You have to do it from the beginning. So okay, so remember keeping something like 1 2 3 4 5 as 5 is the length, and for the j it's an internal second loop. Let's for the beginner, let's have something like if I equal to 1, then what can be the values of j. So what can be the values of j? Here it's given as for I to length, and what's the I? 1, and what's the length? 5. So we have 1 2 3 4 5, and for I equal to 2, j will start from 2 3 4 5, correct? So this is how it's done. Now once this is done, like this is for second, you have to do till I equal to, I think when I is 5, then j will become 5. That's it. So the numbers are gonna reduce because it's starting from I, and you have to trace out what will be the value of sum here. So for I equal to 1, the sum is given as error of j minus error of I. What is ARR? This is the element. So this is 1 2 3 4 5. Okay, so for the I equal to 1, j, so error of j is that is error of 1, which is 1 minus 1, sorry, error of j, right? So error of 1, that is 2. So and error of I is also 2, so 2 minus 2 is 0. Next it will be 4, as the j value is updated to here, and we are subtracting 4 minus error of I is still 1, which is 1 again. So 4 minus 2 is 2. So we are gonna get something like 2 4 6 8, as at the end when j is equal to 5, that is 10, and I is still 1. 10 minus 2 is 8. And for this and the next loop, it starts from 2, that is it starts from here. 4 minus 4 is 0, 6 minus 4 is 2, and 8 minus 4 is 4, and 10 minus 4 is 6. And same way, when it starts from this I equal to 3, then it will be 0 for the first index, and that is the third, and 8 minus 6 is 2, and 10 minus 6 is 4. So this way if we traverse out, I think if you sum up, and this will result in 20, and this whole will result in 20, the answer will be, total answer will be 40. So that's how you have to trace it out. And remember, this is the way you can basically like trace out if it's a multiple loop. take the first loop, and for the if it's a one index, what is the values of j? If it's values of j is like that, trace out the array, make the index here, and try to solve it. If it's a single loop, it's pretty easy. You just have to add it here, add the array, and just do it. But if it's a multi loop, try to do a formula, and once you have the good practice of it, then you can like map it on your mind itself when you're doing. If you're well and confident about that, then yeah, you can go ahead and directly like solve the questions and in a more shorter time. Okay, coming to the next question. We have x equal 15 while x greater than 0, print x mod 5, and x equal to x minus 5. Okay, so there's some multiple prints going on because print is added inside the while, and while is getting closed here. So what is we are printing? We are printing the reminder, that is modular division. So and x value is 15. Okay, let's keep x value is 15, and when x value is 15, let's assume print x mod 5, and 15 is divisible by 5, so definitely the remainder is 0. So first value that's going to print is 0. Next, x value is x minus 4, that means 15 minus 4, 11. For 11, when it's divided by 5, we get 1 as the output because 1 is the remainder. Then again 11 will be subtracted to 4, which is 7, and 7 when divided by 5, which that will be 2, and 7 minus I think 4 is 3, and when it's divided by 5, so basically we'll get the same number 3, and when we again subtract, this will be in minus 1. This where x greater than 0 condition fails, so we're not gonna print anything, we're gonna exit, and the correct the values that are gonna print is 0, 1, 2, 3. So that's the output for this question. Next, fifth question, n equals 7, a equals 0 for I from 1 to n, from a equal to a XOR I. Oh wow, XOR. So this where bit operations comes into place. So I think initially I added something about exception errors, and this is a I think second point. So first one was exception. So whatever I'm adding, just make sure have a go through of these topics and understand or solve more about it to understand, because doing a for loop and print might be a little easy, but to understand these kind of concepts and trace out the outputs, it will be difficult until unless you know the concept. Okay, where were we? From I equal to 1 to n, a XOR I. So we have 1 to n, that is 1 2 3 4 5 6 7 7 a XOR I. So XOR is basically like how XOR works is like if there is a 0 0, the output is um, 0, and if it's a 1 1, then output is 0. But if it's an 0 1 or 1 0, that output is 1. So if the bits are different, then in that case only the result is a 1. Otherwise, if it's same, whether no matter 0 or 1, we'll get 0. So this is a basic like on the high level, but I would request you to go to all the bit operations and how exactly this works. Now coming to a XOR I, a will start from 0. So basically it's doing 0 XOR 1, 0 XOR 1, that is 0 XOR 1, which will result in 1. So current a value is 1. Next, for the 2, here the numbers are again converting into bit. So 2, when we convert into the bit format in the base 2, then we'll get something like 1 0. So we are doing 1 0 bit twice, that is XOR to 1, 1 is 0 1. So if we do that, then it will be 3, correct? Now next value is 3, and if we do 3, that is 1 1 XOR 1 1, which is like same, then result is 0. That means after this iteration, a value has returned to 0. Okay, next we have 0 XOR 4, so that means 0 and 4 is 1 0 0. Okay, I hope it's correct. Yeah, it's correct. So this 0 0 will result in 0, but and this is also 0, and here it is 0 1, so 1. So we have a value as 4. The next iteration when it's 5, so basically we are doing 1 0 0, and 1 0 1. So this will be 1 0 and 0 again. So a value will come to 1 again. And here again we are doing XOR with 6. 6 is basically I think 1 1 0, which is 1 1 1, because all are different, so you'll get number as triple one, which is in the in the normal format it's 7 of for the base 10. So after 6 we got a value as 7, and next value to be doing, and it's the same numbers how we see for 3. So if you do 7 7, that is 1 1 1 and 1 1 1, and both are same, we know for both are same, it will result in 0. So it will be 0 0 0, and if it is a 0, the answer for the a will be 0. So I know it might be a little confusing for the ones who don't know bitwise operation, so I would just go through it. But on a high level, this is how it works. Any number will get converted into base 2, until unless they explicitly call out if there's another base, but ideally it will go to the base 2. Then we have to convert into the specific base. So for 0 it is 0, for 1 this is 1, for 2 it is 1 0, for 3 is 1 1. So we have a bitwise format for all the base 10 numbers. So in that format it get to the XOR, and that's how like we can solve these questions. So that's why go through bitwise operations, and I think when you go check on the binary formats as well. Okay, let's go to the next question. What is printed 1 2 3 4 5 sum equal to 0 for I from 1 to length of a sum equal to sum of a of I into I, for instance. Okay, I think it's pretty simple. We have 1 to 5 and we want a of I into I. That means 1 into 1 and 2 into 2. Next is 3 into 3. Next is 4 into 4 plus 5 into 5. Okay, 1 plus 4 plus 9 plus 16 plus 25. Just add 2. 1 plus 4 plus 9 plus 16 plus 25. So we got answer as 55. So answer is 55 this for this question. Okay, and how did I solve this? Because I remember in my mind that we are iterating from I, and I values from here to here it's going, and I'm just having a assumption we are moving a pointer in our mind. That's how I was doing. But try to keep a practice on it to like move at this speed and try to solve as many as questions possible. Okay, up to 7, s equal 1 0 1 1 0 0, count for I from 1 to length of else. If s of equal to I, then count equal to count plus 2 of length of s minus I. Oh, awesome. So when s of is equal to I, then we increment. That means we have this. So we can see count plus count is currently 0 for the first iteration. So what are the iteration? 1 2 3 4. Okay, for the first iteration, and anyway second iteration will not be there, so third and the fourth. Okay, when I equal to 1, it is 2 power length of s. So length of s is 1 2 3 4 5 6. 2 power 6 minus 1, that is 2 power 5, which is 32. And for and x equal to 3, it is 32 because count is updated, plus 5 minus 3 is 6 minus 3 is 3. 2 power 3 is 8, so plus 8, which is 40. Next for index equal 4, 40 plus 6 minus 4 2 square 4, which is 44. I hope my answer is correct. Yep, the answer is 44. Okay, going to the next question. 5 4 3 2 1, max equal to a of a for I from 2 to length of a greater than max, and max equal to a of a, and if. Okay, this is pretty simple. What they have done is they put the max value of a of 1, that is a of 1 is 5. That means max is initially declared with 5, and as it's already declared, so they are moving from 2 to length of this, and they're comparing max with the a of 5. If any element that is greater than the max, which is greater than 5, then update it. But if you see 5 is already max, so there is no way no other element can go and update. So for the answer for the max will be 5. Next question. Test output n equal to 10 is equal to 0 for I from 1 to n, I and I equal to 1. Okay, and then c equal to c plus 1, and if n for, oh, this is 1 2 3 4 5 6 7 8 9 10. Okay, I and 1. So okay, I and 1. So I and 1 means we are not taking on the index, we are taking on indexes. So 1 and 1 is equal to 1, that can only be possible, and AND operator works in such a way that the last bit should be 1. That means 1 and 1 only will be 1, whether it's 0 and 1 or 1 and 0 or 0 and 0. Any other cases, this is 0. For only if both are 1, that is 1. And we know in bit operations 1 is only possible in odd numbers. Okay, so basically if we are going for each odd number 1 2 3 4 5 and we are incremental count, so basically answer should be 5, and that's correct. The answer is 5. Okay, I'm coming to the next question. 2 3 2 3 2 sum 0 from I equal to length from I plus 1 equal to length. Okay, again I equal to 2, sorry, 1 2 3 4 5, and when I equal to 1, j will be I plus 1, that is 2 3 4 5. Okay, and when it's 3 4 I think when it's 5 it has to go, but it is beyond the length, so there will be no. So what it is checking, if a of I equal to a of j, then sum equals sum plus 1. Basically they are checking a of I equal to a of j, and j is always, oh okay, j is iterating, right? So okay, so if we take the point right here, it's comparing whether the right side element any other occurrences of it. So for this one we know this and these are equal, so occurrence is 2. And for this one 3, we know 3 came next again, so update it to 3. Next for this one we see 2 came once again, so update it to 4. So for the 10th question, answer is 4. Okay, output x equal 3 4 0 from 1 to y into what is y 4 1 2 3 4 5, z equals z plus x, z is 0 and z plus x is 3. So basically we are doing plus 3 every time, so that means every time we are doing the plus 3 for 4 times, so 3 into 4 it's 12. So 12 is the answer. Next, what level is pal equal to for I in length of s, and so basically they are iterating from 1 until half of the element, and they are checking whether the I index is not equal to, okay, these basically result in the last index. I mean, if you're taking the first index, so they're triggering the last index. If you're taking the second index, it will be last second index. This way they're comparing, and they're checking if they are not equal, that means is pal is false. I think is pal is basically they're indicating that is it palindrome or not. It's a palindrome is a concept where if we treat from start to end or end to start, both are equal. So the example is 11, so LEVEL, if we read it from the right side as well, LEVEL, so both are same. So it's a palindrome, and we say palindrome if it's true, then we are just printing, so the answer will be just true. Output 1 1 2 3 5 sum equal to 0 while I is less than equal to length of a, sum equal to sum plus a of I, a equal to I into 2. Okay, so we have this so sum is 0. Let's take I values 1 2 3 oh no, this we are not linearly taking, right? So I value will be 1, then it's updated to 2, then it's updated to 4, then it's updated to 4 to the 8. So when I value is 1, sum was initially 0, so 0 plus a of I, that is 1, so sum value will be 1. And for what you call I equal to 2, this will be 1 plus a of 2, that is 1 plus 1 is equal to 2. And 4, 1 2 3 4, for 4, 2 plus 3, that is 5. And for 8 it crosses the length, so we gonna break. So answer for the 13th question is 5. Next question, 2 3 5 7 line, count 0 for I from 1 to length and equal to 10, then count equal to. So basically they are checking the loop. The loop is running from 2 3 4 5 from here, and also second loop is also starting from here, and it's not I. So every time we take the element, we want to check the left one on the right one both. So that means if we're taking 2, that is the first index, we are going to check 2 3 5 7 and 11. Even if we take the element 3 for the ith index, we gonna again check 2 3 5 7 11, because here 1 is given, not I, because in other questions it's going to start with I or I plus 1, but it is 1 given, so we have to check the array again. Now they're asking us if a of I plus a of j equal to 10. Okay, that means we have to check any sum is equal to, and that can be the sum in the number itself, because we are repeating. So if we check from the 2, there is no way 2 plus anything can be 10, but for 3 we have 7, so 3 comma 7 is one combination. And for 5, 5 plus 5 is one combination, because we can take the number itself. For 7, as we can take the left side also, because we are going to travel from starting, so it's gonna be 7 comma 3 combination. And I believe that's it. So answer for this is 3. Output n equal to 8 equal to 1 for I from 1 to n, a equal to a into 2, I if I equal to 3, then break n diff. So we are only iterating, even though the loop is from 1 to 8, when it reaches to 3, we are just breaking it. That means 1 2 3, we have to trace out output till 3. A equal to a into 2, that is a equal to 1, so 1 into 2 is 2, 2 into 2 is 4, 4 into 2 is 8. So answer for this is 8. 4 4 4, x equal to a of I, and from 2 to length x. Okay, so basically this is a tricky question. So basically if you haven't practiced this question before, then the candidate gonna take some time to utilize on this question, but that's gonna waste time on you on providing some efforts on other question. This is like a tricky question here, because even though if you trace out the XOR equal to a of I, you will get the output, but always remember that if there are same numbers given and the operation is XOR, always remember even and odd. If the number of the same number is even, the output is always 0. If it's odd, the number itself. Okay, so here the even, so the for the even output is 0, you can directly mark as 0. Just a 1-second job and you go to the next question. Trace output A, B, C, D, E, T, and for I from 1 to length of S. If I mod 2 equal to 1, then T equal to T plus S of A, and if. Okay, so I mod 2 equal to 1, 3 equal to T of S. So that means we're basically taking odd numbers, the 1 is given, then T equal to T plus S of I. And if you're taking odd numbers, then it will be A, C, E. The answer will be A, C, that is S. And that's correct. What prints 1 2 3 4 sum equal 0 for I from 1 to length of A, for j to length of A. Okay, remember j is starting from I, and sum equal to j minus I plus 1. Oh, so we are not basically utilizing this array at all, only we are using for the length. So j minus I plus 1. So okay, that will be like a too many combinations. So basically for I equal to 1, j will be 1 2 3 4. For 2 it will be 2 3 4. For 3 it will be 3 4. For 4 it will be 4. So if we do it, j minus I plus 1, so 1 minus 1 plus 1 1, 2 minus 1 is 1 plus 1 3, 3 minus 1 3 minus 1 2, and 2 plus 1 is 4 6. So I think it's just a time consuming. If you just trace out values based on just subtracting this and this and this and finally add it here, you're gonna get a sum of value 20. So answer should be 20 here. Output n equal to n, count equal 0 for I from 1 to n, from j from n, and step I. Okay, this is step. So basically step is something like, even in Python, something, if you remember, in range we keep like n. That means by default start will be from 0 and end will be till n minus 1. That's the assumption. But there is one more hidden argument called step, which is by defaultly 1 in Python. So if someone is mentioning range of 1 to n, that is 1 to n minus 1. If they are giving 1 to n comma n, that means every time there's a loop just add plus 1. But if you keep 2, every time the next loop add plus 2 instead of plus 1. So that's where step comes. And here step of I indicates every time we are iterating the j, we have to for the first iteration when I equal to 1, that means the step will also be equal to 1. For I equal to 2, step will be equal to 2. That means for I equal to 1, let me, okay, let me take a pen again. For I equal to 1, j value will be from 1 to n, right? So n is okay, so this will be 1 2 3 4 5 6 and so on till n. This will be 9 elements. And for I equal to 2, this will be 1, it will be 2, it starts from 2, that's step 2, so it will be 4 6 8, and it's gonna be 10, so we cannot take it, and it's 4, and so on. If when I equal to 9, then it will be number 9 itself. I think even for n equal to 8, it will be j equal to 8. Remember that even though its step of 9 is there, we have to consider the first element, even if it's like for of 2n 2 9 and step is 9. That means you cannot assume that 9 is the next step of 9. You cannot just ignore that. You have to take the first element, that is 9. So, and they are asking how many iterations, because each and every time we are just increasing. So if we just sum this up, the number of iterations we gonna get is 23. What means 1 3 2 6 4 from for I from 1 to length of a. If a of mod 2 equals 0, that is even number, then append a of I and if. Okay, so basically they're asking just append a of I, and whenever a of I is even, that means we are gonna append, that is add these numbers to here when it's even. So let's call the even 1 2 3. So there are 3 even numbers that are gonna add, and they are asking length of v. Answer is 3. Okay, 21 aba bab count equals 0 for I from 1 to length of s minus 1. If adjacent elements are equal, then count plus 1. Okay, are there any adjacent elements equal? No, there are other elements are equal, but those are not adjacent. That will be I plus 2 but not I plus 1, so count value will be 0. It is 1 2 3 4 5 I equal to y, I is less than equal to length of a, remove a. I equal to I plus 1 and while. Okay, so it's a tricky one, because when you're iterating it, you're gonna remove I of I, and I value you have to remove based on the current element index of it, because if you take current a equal to 1 2 3 4 5 length of a, and I value is 1, that is 1 here. So we are, what is your a of I? So that is I value is 1, so we are gonna remove 1 from here. Okay, so now we have 2 3 4 5, then I value became 2, so I became 2 here. When it's I became 2, when again the loop enters in, we remove a of 2, then you should not remove this, because we have removed this. So this will become index 1, not index 2. That's the trick here. So if this will become index 1, the index 2 is here, and we are doing a remove of a of 2, that means we are going to remove this. Now we have 2 4 5, and for them again it will be index is again becoming 3. So for 3, 1 2 3, the third index is 5, we have to remove 5. And after that we what you call it will be 4, and 4 is of course not less than length of a, because the length of a is 2. So the loop gonna break, and length of a currently will be, answer is 2. 2 2 2 2 for I from 1 to length of a, sum plus a of into a of mod 2. Okay, a of mod 2 is always okay. So a of I into a of mod 2, that means we have from length of a 1 2 3 4 5, 1 2 3 4 5, sum equal to 0. A of I is 2, 2 plus 1 mod 2, 1 mod 2 is 1. Okay, if it's odd then we're gonna 1, but if even it will be 0. Okay, a of it will be into, right? So 2 into 1 2, so value is 2. Next is for value of 2, for when the index is 2, this is 0. So 2 plus 2 into 0 is 0, so 2. And for value of 3 we get index, so a of 3 is 3. 3 into 1 is 2 plus 3 equal to 5. And for 4 value will be 0 again, so 5 plus 0 is 5. And for 5 it will be 5, and 5 into 1 is 5, answer is 10. Did I do anything wrong? Sum is 0. Oh, why did okay, I missed it, sorry guys. Sum is 0, a of I is 1 only, and a of mod is 0, not 1. So if it's 1 here, then the next element will be 1 plus so 1 plus 3 plus 5, that is 9. Yeah, sorry, so that's what I was assuming. Okay, so that's the answer for this. Coming to the next question, x equal to 1 for I from 1 to 1 to 5. Oh, okay, that's a typo. Just assume it's a new line. Okay, so I from 1 2 3 4 5, x value are just adding up, and if x becomes greater than 6, we're gonna subtract by 2. Okay, so x plus I, x is currently 1. Sorry, for value 1 x becomes 2, for value 2 x becomes 4, for value 3 x becomes 7, and the moment it becomes 7 it's greater than 6. So we are doing oh, sorry, I missed it again. So for the value 1 x becomes 2, for the value 2 x becomes 4, for value 3 x becomes 7. So the moment it becomes 7, it passes this condition, we have to subtract by 2, so x becomes 5 again. So in the next iteration we have to do sub add, so x equal to 9, and still this is greater than 6, so we have to do minus 2 7, and next iteration 7 plus 5 12, and 12 minus 2 10. So answer 10 is the correct answer for this. Okay, and what prints 1 2 3 2 1, 1 for I from 1 to length of a, p equal to p into a of I. That means we are doing 1 into 1 1, then into 2, that is 2, 2 into 3, that is 6, 6 into 2, that is 12, and 12 into 1. So answer for the 24th question is 12. 0 1 0 1 1, 1 is equal to 0. For I from 1 to length of n, 1 is equal to 1 plus a of I. Okay, so basically we are just summing up in the value in the ones. So if we sum up, that will be 3, because there are just 3 ones. Ones will be 3, and we are asking 3 into 2, and 3 into 2 is 6, and 6 greater than length of array. What is the length of array? 1 2 3 4 5. So basically they're asking 6 greater than 5, and it is yes. Then we have to print majority. Answer is majority. What prints 5 3 5 4 3 2 1 swaps equal to for I from 1 to length of a of minus 1, for j from 1 to length of a, for a of j greater than j plus 1, then swap a of j comma a of j swaps equal to swap plus 1. Okay, so basically I think this is somewhere similar to a bubble sort algorithm. Maybe I think the first, second I inform, third just check on the sorting algorithms as well. They're just checking how many swaps it's gonna take to basically sort it. I think at the end we'll be having the sorted array. So for j from 1 to length of a of I minus 1, we are checking if these two are greater than not. That means 5 4 3 2 1. 5 is greater than 4, yes, both will be swapped, so it will be 4 5 3 2 1. Swap count is 1, and next will be 3 5 2 1 2. This will be 3 2 5 1 3, 4 3 2 1 5, which is 4. So we have 4 swaps. And next for j from again when I is 2 again, and I is 2, we are checking from 1 from j comma j greater than 0 and 0. Okay, so this way you have to do the swapping, and you have to trace out the output. I think if we trace out the complete loop, it's gonna take time. So basically it's somewhere similar to bubble sort. So if we do this, we're gonna get the answer as number 6. 6 is the output for this. Okay, and output 1 0 1 0 1, r0 for I from 1 to length of a, r equal to r into 2 plus a of I and 4. Okay, this another line, and okay, r into 2, okay, from 1 a of I. What is the length of a? 1 2 3 4 5. We have length as 5. For index 1, this is 0, because 0 into 2 is 0, 0 plus 1 is 1, so r value is currently 1. Then next is for value 0, so there will be no addition, plus okay, 1 into 2, right? So the r value is equal to 2, and there is no addition here. For I equal to 3, so it will be first is 3 into 2 6, and 6 plus a of 1 is 1 7, and next is into 0, so we just multiply into 14, and then 14 plus a out of I, that is 14 into 2 28 plus 1 29. So answer for 28 is 29. Oh, just a second, let me take again 2, and the next time it goes to this is 4, and 4 plus 1 is 5, and next is 10 into 2, oh sorry, it's 21 not 21, because I took a mistake of having assumption of 7. So for the first iteration, it will be r into 2, that is 0 into 2 will be 0, and for the second iteration it will be 2, and it continues, and here we assume it as 7, it will be basically 5, and it becomes 2, that is 5 into 2 is 10, and 10 into 2 is 20, and the last element plus 1 we add it, so it will be 21. So 21 is the answer for this. So what prints? N equal to 5 for f equal to 1 for I from 1 to n, f equal to f into I. F equal to f into I, then f greater than 50, then f equal to f minus 50. So we have to just make sure of that. So value is 5. So 1 into 1, it's 1. In the next iteration, into 2 is 2, into 3 is 6, 6 into 4 is 24, and 24 into 5 is I think 25 and 120, and if we do minus 50 of 120, it will be 70. Answer for 29 question is 70. Output 2 3 5 7 11 13. It's an odd numbers and 9 is missing. Okay, for I from 1 to length of a, if a of a plus 1 minus a of I equal to 2, then sum equal to sum plus 1. So basically it's like a counter, and they are asking if the right minus left is equal to 2 or not. So here there's no second loop, so we're gonna check the adjacent and we'll see if any 2 is there. So yes, 1 and 2, this is not, and 3, so answer will be 3 here. So output for the 30 question is 3, because it's not a second loop. If it's a second loop, then we would have taken all the combination, but it's a single loop, we are just taking the adjacent elements, and as per adjacent element we have only 3 combinations. What means race car count equal to 0 for I from 1 to n. If s equal to a, then count equal to count plus 1, and if it's just like number of occurrence of a, that is 1 2, answer is 2 for this. Okay, next question. 1 2 4 8 16 for I from 1 to length of a, x or a of I. So or, so we have like checked x or, and for or, interesting case is 0 0 only will result in 0. If it's 0 1 or 1 0 or 1 1, anything is just at least 1 1 can result in 1. Okay, for from I to length of a, x equal to XOR of a of I, that means 1 is basically 0 1, and this is 1 0. 1 or 2 is basically 1 1, and 1 1 of 4, that is 104, is 1 1 1, and 1 1 1 of 8, which is 1 0 0 0, is 1 1 1 1, and 1 1 1 of again 16, which is on this many zeros, that is I think 1 1 1 1 1. So this is 1 2 3 4 5. I believe it will be 31, I guess. 32 question, yes, answer is 31, because it's basically 2 power 5 minus 1, 31. So what the trick here is, like as we do or, even if there's a 1 in one of the last bit, we just keep it as 1, but here the numbers given in such a way that every time we do, we are getting all ones. So every time we are doing all ones, so first will become 3, and the next bit will become 7, so it keeps on goes on until we get a 31, which is all ones. Okay, what means 3 1 4 1 5 sum equal to 0 for I from 1 to length of a, for j from 1 to length of a, sum equal to sum plus a of j. So that means basically j value can be 3 1 4 1 5, or it can be 1 4 1 5, and it can be 4 1 5 1 5 and 5. So 3 1 4 1 5, 3 8 and 9 14, and 5, this is 11 10 6 5. If we add all this up, we're gonna get the number as 46. That's the answer. Okay, coming next question. Output x equal to 0 for I from 1 to n, for j from 1 to I. If I into j mod 2 equal to 0, then x equal to x plus 1. So we are having a counter here, and we want to see if any multiplication is in even. Okay, 1 to 10, and we are also taking 1 to I. Oh, okay, so that means for I equal to 1, j value will only be equal to 1. For I equal to 2, j value will be equal to 1 comma 2, because they gave 2i, not from I. And same way, equal to 3, it will be 1 2 3, and when I is equal to 10, j value will be 1 2 3 4 and so on till 10. Yeah, so you have to find out I comma j. So 1 into 1 is not, so 1 into 2, yes, 2 into 2, yes, So we have to find out how many times this x equal exponent 1. So if we trace the output, then we're gonna get 40 as the answer for this. Okay, sorry. 1 2 3 4 5 reverse from I from length down to 1, append reverse of a of I, and for reverse of 3. So we are basically iterating from length of a, that is 5 to 1. That means index is going like 5 4 3 2 1. If you go here and append that elements to the array revision or rev, that means the elements will be in this order. So we are asked ref 3, that is this one. So answer will be 3. Okay, next is ABC 1 2 3. For I from 1 to 0, S is greater than 0, S. So here you see only the ABC will not be counted because those are not numbers, and it doesn't come, and this will not be satisfied. But for the 1 2 3, those are in between 0 and 9. So it's just like a counter, and there are 3 numbers. So answer is 3 for this. 1 2 3 4, sum 0 for I from 1 to n. If I is less than equal to, then sum is equal to sum plus a of I, else sum plus 2 into a of I. I is less than equal to 2. That means let's, for I equal to 1, sum is sum plus a of I, that is sum 0 plus 1 1. This is 1 plus 2 3. Then for the 3 and 4, sum will be sum plus 2 into a of I. 2 into it is 6. 2 3 sorry 2 3 is 6, and 6 plus 3 is 9, and 9 plus 2 into 4, 8 plus 9 is 17. Assume answer for 37 is 17. Yes. 38, n equals is count equals 0 for I from 1 to n. If n mod I equal to 0, then count equal to n. So basically n is 6. Okay, n is 6, so 6 mod I. So basically from we are doing from 1, so they are asking what are the divisions of 6, so what are the numbers that can divide 6 till 6 and including 6, because n we have to take care. So 1 can divide, 2 can divide, 3 can divide, 6 can divide, and we have 4 numbers, so count will be 4. Answer is 4. 1 2 3 4 5, k equal to 3, sum equal to 0 for I from 1 to length of a minus k plus 1, temp equal to for j from a I minus k, temp equal to temp of 1. If temp is greater than 6, then sum equal to sum plus 1, and if n for. Okay, so what is happening here? From length of a is 1 2 3 4 5, and 5 minus 3 is 2, 2 plus 1 is 3. So I value is going from 1 to 3, and temp is 0. For j value is going from 1, and 1 plus 3 is 4, 4 minus 1 is 3. So j value will be 1 2 3 at the starting. Next the j value will be 2 2 plus 3, 5 5 minus 1 4. So it will be 2 3 4. Next it is 3, 3 plus 3, do we updating any value in the k? No. 3 plus 3 6, 6 minus 1 is 5, and so it will be 3 4 5. So we have this, and we want to add temp equal temp of I plus 0, and the next will be like we basically 1 2 3 2 4 5 3 4 5. If we add these elements, so it is like 1 2 3 2 3 4 3 4 5. Okay, it's the same array, also same, right? 1 2 3 is 6, and 2 3 is 5 9, and 3 4 7 12. So if we add all this 39, we gonna get, oh, so okay, sorry, we missed one point. We have these conditions as well. So if we add this 6, it's not greater than 6, so it just goes on. But for the next one, the moment we add 2 to here, that is when it becomes 8, we have to we have to, like, my bad again. So when there is greater than 6, then we have to increase by 1, and we are not decrementing it. So when it's greater than 6, we are actually just having a counter here, not the sum. So when it's greater than 6, 1 2 3 4 5 6 3 6 times are the ones which we saw that is happening. But you see the for loop for j is ending here itself, so we cannot consider j iteration. So these are like I iterations that they are mentioning because it is part of I. And you see end for is happening for j, and for is happening for I later. This condition, this is for I. So in that case we have only two times that this is happening, that is answer is 2. Coming to the next question, 2468 a of 1 for I from 2 to length of a GCD. It's like the greatest common divisor, and g of a of I. So basically a of I is 2 and 2 comma 4 is 2 greatest common divisor, and 2 comma 6 is also 2, and we anyway have 2 and that is a common divisor. So no matter what you do with the 2, so answer will be 2. What means a b b c c c, and for I from length of I, if I mod 3 is equal to 1, then t equal to t plus s of I mod 3 equal to 1, that means 0 mod 3, that is 1 1. Oh sorry, modular division, right? So 0 mod 3, that is sorry, 1 mod 3 is 1. So if it's 1, t equal to a, that is a comes. For 2, value will be 2. For 3, value will be 3. For 4, value will be 1 again. That means fourth index is b, so next we have b. And for 5 again it's 2. For 6 again it's 0. For 7 it's again 1, so value will be c because the seventh index is this, and same repeat. So basically we'll be having abc since we just appending that index, so value of print will be abc. 5 4 3 2 1 I equal to sum is less than length of a, sum equal to sum plus 1, I equal to I plus 2. So basically we have I that is from 1, the next I is 3, next I is 5, correct? Sum equal to, so a of I, that is 5, 5 plus 3 plus 1, so basically this should result in 9, 42. Yes, 9 is the correct answer. What means x equal to 1 for I from 1 to 4, for j from 1 to 3, x plus I into j. So we have for 1 we have 1 2 3, for 2 we have 1 2 3, for 3 we have 1 2 3, 4 we have 1 2 3. So it's x equal to 1, right? So 1 plus I into j 1, that is this become 2, and 2 plus 2 into 1 2, 4, and 4 plus 3 7. So this way if you try to iterate it, the answer for this you're gonna get is 61. Okay, 2 1 2 1 2, major is 0 for I from 1 to length of a, count equal to for j from 1 to length. If a of j is equal to a of I, then count equal to count plus 1, and for count greater than length of, then major. So basically they are like starting, they're iterating this array 2 and starting from 1, they're checking this and the number itself and the other left and right of element. They're checking basically the occurrences of it. If you see 2 has occurred thrice and 1 has occurred twice, and they're asking what is greater than length of a by 2. Length of a by 2 is 1 2 3 4 5. 5 by 2 is like, if you take the floor division, it is 2. The number that is greater than 2 is 3. So then majority is equal to a of a, the majority is 2. Okay, move on to the next question. 45th question. We have an array 1 3 5 7 9 for I from 1 to length of a, for j from I to length of a. We're appending a of j minus a of I, and we are printing print b of length of b. That means basically we're printing the last element that's gonna insert. We know that I is gonna go till length of a. That means I can go 1 2 3 till 5, and j will also go till 5. So definitely last element will be a of 5 comma minus a of 5, as both elements are same, that is 9 minus 9. So answer should be 0. Okay, answer for this is 0. And going to the next question, output 111000, max sequence for I in length of n. If s equal to I, then car equal calculus, else car equal to 0, and if. Okay, so if 1, then we are actually like incrementing the current sequence, and based on whether it is the max sequence or not, we are updating. So if you see, initially it will be 0, and for this one it will be incremented by 1, and when it moves to the next index, it will be incremented by 1 again, so that is 2. Then next 3. Next next it will check if 3 is greater than max sequence. Yes, it is greater than, so max sequence will be greater to through 3, and max sequence is equal to 3. Yes, and once again if it goes, it becomes 0, then what you call, the string is 0, then current value will be 0, and it keeps on iterating. And again when it comes to this one, again it will update with current equal to 1, since 1 is we have seen, but 1 is not greater than 3, so it will ignore. So after traversing till this one, current will be 3, so even 3 is not greater than 3, and max sequence is equal to 3. So that's the answer for this. Coming to the next question, what means 1 2 3 4 5 0 for from 1 to length of a. Okay, 1 2 3 4 5, yeah. And for I from 1 to length of a, x equal to x plus. Okay, x is 0, so for the first index, 0 plus a of 1 is 1 into 1 minus 1, so that is 0, so 0 plus 0 is 0. But for the second, it is 0 plus 2 into I minus 1, that is 2 minus 1, 2 minus 1 1, so answer is 2 for the second index. For the third, we have 2 already, 2 plus 3 into 3 minus 1, that is 2 6, 2 plus 8, and next 8 plus 4 into 4 minus 1 12, so that is 20. And if we do this for the 5, after adding up all the values, we should get the output as 40. Okay, because it will be 5 minus 1, that is 4, 5 4 is 20, and we already have 20. 20 plus 20 is 40. Answer is 40. Coming to the 40th question, n equal to 4, p equal to 1, for I equal to 1. So we have 1 2 3 4, and p into, so 1 for the first index, p into 2 power I, 2 power 1 is 2, 2 minus 1 is 1, then next plus okay this, and for the next one it will be 1 into 2 power 2, that is 4, 4 minus 1 is 3, so 3. So next is 3 into 2 power 3 is 8, 8 minus 2 power 3 is 8, 8 minus 7. So if we just directly multiply all this after the fourth iteration as well, we basically will be having like 1357 into, so 1 into 3 into 5 into 7. If we multiply these values, then we gonna get the output as 105. Okay, let me, it's 3 into 5 is 15, 15 into 7 is 105. Okay, so that's the 48. Coming to the next question, what prints 1 2 1 2 1 2 sum equal to 0 for I from 1 to length of a minus 1. We are checking the adjacent elements, and if they are equal, then sum. I don't see any adjacent elements are equal, so sum will be 0. Okay, Coming to the last question for today, we have 4132, target equals 6, round equal, found equal to false. Okay, and for I from 1 to 10 and j plus 1. Okay, so we are keeping the I here and iterating from j to the from the next element towards the right, and we are checking if a of I plus a of j equal to target then found. So we need to find any element I and any right side element that is equal to target, a summation of that. So we have already have 4 and the next is 2, so 4 plus 2 is 6, so definitely target will be found, and there is no condition where the target is again updating into false. Sorry, the found is again updating into false. So that means once we have the true, no matter whatever output we have, so it will not be get updated to false. So print found will get the output as true. So yeah, I think that's all about all the 50 questions. So it's a long short video, like we have solved all the 50 questions, and we have like it does I think a lot of patterns here. And I think if I remember, we also discussed that we you need to check on the exceptions and errors part, and binary or bit, and the third one oh yeah, I think one there's a sorting algorithm, that one. So yeah, so I think if I remember only these three, so from this pattern I was able to derive like these three are required for you to like understand the questions and doing more easy way than like uh, doing all the what you call tracing out all the output. That would take time. And also there was one shortcut for even XOR, odd XOR, so that you can able to figure out if you're do more practice on this. So yeah, I think that's all for this video, and all the best for your exam, and do let me know if you have any questions, or if you think anything can be added, or any type of questions you want. So all the best again. Thank you.